और सब बढ़िया।
यस सर।
कैसी चल रही हैं आप लोगों की क्लासेस? हाँ जी,
चल रही है सर।
टाइम
अच्छी
टू
चल।
टाइम
हाँ जी,
टाइम टू टाइम
टाइम टू टाइम चल रही हैं। ओके, राइट। सो आई थिंक यू मस्ट बी एंजॉयिंग द ऑनलाइन क्लासेस। क्यों?
नो सर।
क्यों? बढ़िया है, देखो घर बैठ के आराम से बिस्तर पे लेट के।
4 साल की डिग्री।
नहीं, 4 तो नहीं, तब तक तो तुम आ जाओगे। क्यों?
सर सेकेंड सेमेस्टर में बुला रहे हैं हमको या नहीं?
नहीं, अभी नहीं। आपने शायद पढ़ा नहीं है ना? नहीं, I think let me tell you if I can find for you. Can you see this website?
यस सर।
यस सर।
है ना, ये लिखा है ना, physical reporting of inform to all concerned that the students of second and third year program shall also report to the institute physically with effect from 1st April as per their convenience and while adhering to COVID-19 this ठीक है, to appear for end semester examination, right? The classes and examination for the students of first year program shall be conducted through online. Some these cases in institute during January 2022 is regulated, है ना?
सर बट इसमें स्पेसिफाई भी तो करा है कि फर्स्ट सेमेस्टर, ओनली फर्स्ट सेमेस्टर स्पेसिफाई करा है।
कहाँ लिखा है?
फर्स्ट ईयर के
हाँ
साइड ब्रैकेट में।
फर्स्ट ईयर के साथ
अभी तो ऐसे ही है, फर्स्ट सेमेस्टर का ही तो है, तो अभी तो फर्स्ट सेमेस्टर पता नहीं कब तक चलेगा आपका। हाँ, तो मतलब आप ये देखो कि बाय द एंड ऑफ मार्च होगा आपका सब कुछ खत्म, एम आई राइट?
यस सर।
हेलो,
यस सर।
है ना? कब से एग्जाम? 13 मार्च से है ना शायद?
14।
14।
हाँ, तो अप्रैल 1 से स्टार्ट होगा एक तरह से। हाँ, 14 मार्च है ना, उससे पहले लैब्स का रहेगा। 13 मार्च तक टीचिंग है शायद, है ना?
11 तक है
इफ आई
सर
एम नॉट
टीचिंग।
रॉन्ग,
11 तक ही
11
है
तक
टीचिंग।
है, ठीक है। ओके ओके, तो लेट मी चेक, है ना? ठीक है, तो आपके लिए तो अभी यही है, ऑनलाइन ही चलेगा अभी, राइट? मतलब अप्रैल में रिव्यू होगा, तो कहीं मई वगैरह में आ पाएंगे आप, है ना? कि आपका तो सब कुछ ऑनलाइन चलेगा तब तक। तो लेट अस सी आपके सीनियर्स का कैसे रहता है ना, उस पर डिपेंड करेगा जो आएंगे ना। क्यों?
यस सर।
है ना, उन्हीं पे डिपेंड करेगा कि वो बीमार हुए नहीं हुए, सब ठीक रहता है, और वी होप कि सब अच्छा रहे और आप लोग आए, है ना। पर तब तक बेसिक इलेक्ट्रॉनिक्स तो खत्म हो जाएगा, क्यों?
यस सर।
Yes, sir.
ये है थोड़ा सा, तो चलो। So थोड़ा टफ है ऑनलाइन क्लासेस, बट आई थिंक फॉर यू पीपल यू विल बी एबल टू हैंडल इट लेटर। क्यों जी, कर लोगे? तो ऑफलाइन क्लासेस हो जाएंगी मुझे लग रहा है आप लोगों के लिए, अगर मई जैसे में लग रहा है मुझे।
Okay, sir. That's good, sir.
Okay, so let us come to the DC analysis topic. DC, in fact, the name of this chapter is DC biasing. This one. DC biasing है। So we know base emitter voltage, this is 0.7 volts in the active region. IC we know it is equal to beta IB. Okay, IE is equal to IC plus IB, or it should be beta IB plus IB or beta plus 1 IB. इस तरह की चीजें पढ़ी है ना। Okay, so today we'll discuss some analysis for this BJT analysis, DC biasing techniques. So if you see, the meaning of this is okay. Can you hear me?
Yes, sir.
Yes sir.
Anybody from Chandigarh? Chandigarh. Anyone in the class from Chandigarh? No. There was electricity crisis there actually. Sorry, I just want to ask. Okay, so this is about the operating points. So if you see term biasing appearing in the title of this chapter is related to fixed level of current and voltages. Okay, or we talk about quiescent point. So operating point we have discussed in the last class. Operating point is related with operating point or quiescent point that is related with IC and VCE. Okay, so we know this characteristics of the output characteristics of a common emitter amplifier, different value of IV, 1 microampere. Like this is VCE, right? And we have just, this is IC. We have drawn a load line like this. Okay. Basically, this is one of the points. So this point and this point, because we have seen that VCC minus ICRC. So when IC is 0, or your VC is 0, so accordingly, these equations, they are coming into picture. So this is VCE. So when VC is 0, this one, so IC is VCC by RC. And when IC is 0, this is equal to VCC. इस तरह से एक लोड लाइन डिफाइन की थी और operating point we have tried to find out. Yeah, means, or what does it mean? This is एक तरह से middle point है. Means if you know this point, it is something like a reference point. Means इससे कम वैल्यू आप लोगे या इससे ज्यादा वैल्यू आप लोगे of this IC and VCE. So you are operating your device. Operation of the device means what is the value of IC actually? We are interested in this. That depends upon IV and beta. Okay. So our device which we are using for our purpose, so this is VCC minus ICRC, whatever input we are giving, this is VCE. So this is this equation. That is how we have drawn this earlier. This Q point is being drawn like this. Now what I say is that if इसको 2 माइक्रोएम्पियर रखता हूँ तो ये 2 मिली एम्पियर हो जाता है, 3 रखता हूँ तो 3 हो जाता है. So or if I move it towards 0.01 microampere, so this is tending towards 0 milliampere or like that. इस तरह से means this device, how it is going to change with the input, that by increasing or decreasing its values, in which region device is going to operate, whether it is going to operate in cutoff, whether it is going to operate in active, whether it is going to operate in saturation. That is what we are interested in. Okay, and for transistor to work is as an amplifier, it should operate in the active region. Okay, so this is what will be our tendency, and in the active region IC is equal to beta IB. That is something what we know. Okay, and if it is in cutoff, so IC should be 0. That is something what we know. Or here VB is, that is 0.7 volts. And if it is going to operate in saturation, what is going to happen? VCE saturation is, that is 0.2 volts and something like. Okay, so that is what we have to see. That's why we talk about either IC or either VCE. These 2 points. because they are going to determine whether the transistor is in cutoff, whether the transistor is in active region, whether it is operating in saturation. Fine. So depending upon this, we can tell us or we can know this V output. This is something like V output. So output is determined because of this operating point. कि इसके कितना इर्द गिर्द आप वो कर सकते हैं, इसको ऑपरेट कर सकते हैं. Means what is the you can say the reference levels or the region of operations of a transistor. So let us see into this, that how it is going to. So this is something what you know. So for the BJT to be operated in the linear or active region, we should be base emitter voltage should be 0.6 to 0.7 and base collector must be reverse bias. That is something what we know. Okay. So similarly for the cutoff and for the saturation region. Okay. Now we talk about the fixed bias configuration. And if you see this circuit, it is something like this. I'll make it a little bit better for you. Yeah, this one. So there are different techniques. I'll explain you what is the meaning of this. Okay. So this is the circuit actually. Right? If you see initially we don't have this. There is no RB. Okay. So the output is VCC minus ICRC. Now we put an RB here, and the purpose of that is to control this IC or this operating points actually. So why we are using these techniques? This is just to control the IC and VCE. We'll see how it is going to control. Okay, by adding this RB in the circuit. We have this C1, we have this C2 in the circuit, right? So if this we have input signal here, तो input signal क्या होगा? AC plus DC कुछ भी हो सकता है उसमें. DC means average value. Okay, what capacitor is doing? Capacitor blocks DC. Okay, so if we do the DC analysis for this capacitor is becoming open circuit. This capacitor is becoming open circuit. Because when we do the DC analysis, that means no AC. Okay, so our circuit is being modified into this. Right? So this is being transformed when we talk about DC analysis. Understand this point? Say yes or no.
Yes, sir.
Yes, sir.
Okay. And what is the importance of these capacitors here? To reduce noise. Okay, this is the coupling capacitors. And they are going to, or they don't allow any kind of noise entering into our amplifier circuit. Because what we want is we don't want any noise entering into our amplifier. Am I right? That's why we have used this capacitor in the circuit. Okay. So what is the purpose of these capacitors? क्या purpose है capacitors का?
To reduce noise.
To reduce noise. Now question is, what is noise? Noise क्या चीज है? Any unwanted signal. Fine. Okay.
Yes, sir.
So this is our circuit. So this is C1, this is C2, this is input signal here from here. अब input कुछ भी हो सकती है, ऐसी भी हो सकती है, anything. Okay. तो output भी इसका amplify version आएगा, right? So we are saying that input is a AC signal, so output will be AC. Output will be AC. So when we do the DC analysis, when we have DC signal, this is going to be open circuit. Am I right? And capacitor is going to pass the AC. क्यों? ठीक है जी, तो इस सर्किट ऐसा बन गया. Now I'll remove this like this. If I see here, अगर इसको थोड़ा सा और modify करूं, so this is something like this. ये भी BCC है, ये भी BCC. So when you start solving the BJT related questions or numericals or circuits, the first thing is write currents and voltages in the system. Okay. So this is something what we have to do. We have to write the AC and DC in the circuits. And first thing is to name the currents. So it is very simple. This current we know it is IB. This current we know it is IE. And this current we know it is IC. This is also IB because ये तो open circuit हो गया इस side से. Okay. So this is how circuit is, or this current circuit is, or we can say our device looks like now, or its operation is something like this. Now what we have to do is, this is the first step. Second step is we have to talk about its base emitter loop and collector emitter loop. These two things. These two loops give us Kirchhoff's voltage laws. Okay, here we are using the KCLs and all. But first thing is to write, we have to write down our voltages. Okay. Can you see it now? Now, if you see, I'll take this circuit. Right, so I need to take this loop. I'll talk about this loop now. Okay. First I must this is plus BCC. This is connected with ground, right? This is RB, and a current of IV is going to flow across this. Okay, and if I take this loop from here to here, because I have to start from a ground and I'll end at a ground. So a loop is being completed. This is base emitter loop. Okay, now if I'll start from point A to point B, from first to two, I'll start from ground and I'll end at a ground. Okay, that means a loop is being completed. Now, what I'm getting is here negative, here positive. We are going from lower potential to higher towards this side. That means it is plus BCC. Current always flow from higher potential to lower. So it is minus IB into RB. Now we are coming across this base emitter voltage, because this is base, this is emitter. So there must be some resistance across this, and there should be some voltage drop. That voltage drop is called as base emitter voltage. So if we write VBE, that means this is at higher potential and this is at lower potential. Okay, so base is at higher potential and emitter is at lower potential for VBE. That means we are coming from higher potential to lower. So this is minus of VBE is equal to 0. Then we go to this ground. So this is how the loop is being formed, right? Now, if I try to find out IB, it is equal to VCC minus VBE divided by RB. And IC, we know it is equal to beta of IB and beta of VCC minus VBE by RB. And here, if you see, IC is dependent upon beta, VCC, VBE, and RB. And if you recognize these three factors, they are transistor structure dependent. Or battery. Like beta is dependent upon which factor? Dopings. Base emitter voltage is also dependent upon doping. Okay. Emitter और base की क्या doping है? Accordingly, there will be drop across it. Its resistance is going to define. VCC is also fixed. But here, it is a RB, which we can change. And we can change the IC accordingly. So we have liberty that by changing this resistance, we can change the IC. So IC can be changed by changing the RB. You can fix it. That's why this fixed biasing technique is coming into picture, because we want the control on Q point actually, which is not there. And if we talk about VCE, that is quite simple. VCE हमेशा इस लूप से बनता है. This is RC, this is VCC. VCC को ऐसे भी लिख सकते हैं. Okay, and this is V output. V output is nothing but this is VCE. Okay, one side is this is higher potential and another side is ground. कि multimeter भी रखेंगे तो इन दोनों points पे रखेंगे, this point and this point. This is how we are going to measure it. So we have to measure, if VCE we have to measure, it is nothing but this potential. ये battery है. We have a drop of ICRC here, and what is left is that is VCC. So again it is VCC minus ICRC. So if you see here again, it is dependent upon RC as well as IC, and IC is dependent upon RB, and VC is dependent upon RB and IRC both. And that is what we want in the circuit, that we want the control over the things, that we can determine that IC and VCE, which is called as Q point, and it should be in the hands of the designer. Okay, Then later it is further modified with the emitter bias configuration. है वही चीज. What we have added is हमने एक और resistance add कर दिया. REB add कर दिया. This is plus VCC. This is V output. This is ground. ठीक है. अब 3 करंट हो गए. So first current is IB, second current is IC, and this is something what we know, it is IE. 2 incoming currents and 1 outgoing current. That's why we know IE is equal to IC plus IB. Okay. So again, we have to take these 2 loops. This is the first loop, and this is the second loop. This is giving us IC, and this is giving us VCE. Okay. So I'll write it 1, I'll write it 2. So first thing we have written is about the IC, that is base emitter loop. Okay. And we named all the currents. So if you see base emitter loop, how to write its equation, we'll start again. बात वही है. इसको कैसे बनाएंगे? This, like this. VCC is represented like this. So we start from this ground in the loop and end at the ground. So loop is being completed. So if I'll start from here, this will be my path to ground. So I'll encounter minus, and then we have plus. This is my plus to minus as current flow from higher potential to lower. Again, this is plus to minus. This is base emitter voltage. And if I take this loop, it is VCC minus to plus VCC. Across RB, it is minus IB RB. Then again, base emitter drop, it is minus of VVE. Then current flows from higher potential to lower potential. This is minus IER is equal to 0. Okay. Right. We know IE is nothing but IC plus IB or beta plus 1 IB. Right. So we can replace this here. Is equal to 0. And if I take this IB towards the another side, that is equal to VCC minus VBE, or this IB is going to become equal to VCC minus VBE divided by RB plus beta plus 1 of RE. This is IB. And IC is nothing but beta divided by this. Beta IB. Okay. So now it is also dependent upon this beta plus 1 RE instead of RB itself. Okay. And if we have to find out VCE, so VCE is nothing but this voltage now. This is RC, this is RE. So it is not VCC by RC now. Okay. So this is IC here and this is IE here. And if we take its this loop, entire loop like this, so if I talk about this, it is, I'll start from this ground. So VCC minus ICRC minus VCE minus IERE, that is equal to 0. From here we can find out VCE is equal to minus IERE. Okay. So as we know, this IE is equal to IC plus IB. This is 1 microampere, this is 1 milliampere, right? So IC is greater than IB, hence IE is approximately equal to IE. ये दोनों almost बराबर से रहते हैं. So this equation can be modified into VCC minus ICRC minus ICRE. Like this. So this is how it is being dependent upon RE, and this is RC. Okay, so this is one another technique which is used for DC biasing actually. DC biasing means we do the DC analysis and we'll try to find out that Q point. Okay, and with the help of these biasing techniques, we have control over the Q point, and that is what we want. इसका मतलब क्या है कि जैसे ही मैं अपना वॉल्यूम अप करना चाहूं, लाइक दिस, गाना बज रहा है, आप वॉल्यूम अप करना चाहते हैं, मींस यू वांट टू एम्पलीफाई इट. कितना कर सकते हैं? सो दैट button is going to tell you the Q point basically. Means how much IC you can increase or decrease. Okay? Understand my point now? Why we are doing this? Hello? The purpose of doing this is क्या पर्पज है? यही पर्पज है कि हमारा कंट्रोल रहे. ओके, ठीक है. So this is another technique which is giving us the DC analysis biasing. देन इन सब से आगे एक और है वोल्टेज डिवाइडर बायसिंग, है ना। सो एक चीज बताओ, आर यू एबल टू सॉल्व दिस इक्वेशंस हियर? ये इनको बनाना आ रहा है आपको?
Yes, sir.
अजीत, आर यू एबल टू मेक इट?
Yes, sir.
कर
Yes,
लोगे?
sir.
ये लूप कैसे बनाने हैं, है ना। So these two things, the first loop is for IC, second loop is for VCE always. ठीक है। और whenever you are solve these numericals, इसके numerical करना आप जैसे ये है ना दिए हुए कर सकते हैं। So if you see what is the difference between VCE and VC, क्या difference होगा VCE और VC में? If you see this question 4.4, sorry, the part C and D, क्या फर्क है दोनों में? So this is the voltage drop between collector and emitter, and this is the voltage drop between collector and second terminal is ground. Fine. So in this numerical, जैसे इस numerical में क्या है, जैसे ये आ रही है, so VCE, this is VCE, but VC means this versus ground, ये difference है, ये point और ये point ground है, that is VC, but VCE means this point versus E, so E ground हो सकता है। VCE और VC सेम कब होंगे? इस केस में, because emitter is connected with ground here. So here VCE is equal to VC, but here VC is not equal to VC. That is the difference. Understand? Hello?
Yes, sir.
And this is voltage between base and collector, और ये base और collector के बीच में। Okay, and if we see, इसका मतलब है base और collector. This is at higher potential and this is at lower potential. This is how you write it. Okay, इसको ऐसे भी लिख सकते हैं, VVC is VVE plus VEC और VVE minus VCE, इन दोनों को इंटरचेंज किया तो साइन माइनस हो जाएगा। ओके, ऐसे कुछ भी बना सकते हो आप, जैसे VCB plus VBC, right, like this. So this is how you write the nomenclatures. So these are the meanings. Actually, once you understand these meanings, you can find them easily. Okay, so it's something like you are putting the multimeter, actually, multimeter at different points. It means you should know how to use the multimeter. आपको multimeter के हिसाब से सोचना पड़ेगा. Any questions regarding these two? Hello.
No,
किसी
sir.
को पूछना हो?
No.
All of you are able to understand this?
Yes, sir.